This is the anaesthetist mask that I'm going to be breathing into. So I'm going to demonstrate a series of experiments now. Firstly, I'm just going to breathe normally. So what this, effectively a gauge, so this servo, which has got a paintbrush attached to it, is being used as a kind of swingometer. So, and it's actually showing flow rate, not actual volume, but it's showing the flow rate. So I'll show you when I inhale and exhale gently over a period of time. Now I'm going to try to rapidly inhale and exhale. So as you see, I'm not calibrated. I'm actually reaching the range, maximum range of the 1024 either way, but that kind of illustrates what's going on. Obviously, if we integrated the volume flow rate, we would get actual volume flow over time, so we should be able to see the actual volume of air being inhaled and exhaled from my lungs. I have to say it feels incredibly responsive. It's absolutely real-time response on this particular servo that I'm getting with my breathing. The correlation between what I can feel my lungs doing and what I see this brush doing absolutely correlates. It's just a bit fucking twitchy. This is the Arduino running the servo. The Arduino is taking as a analog input, it's taking the output from the pressure sensor, differential pressure sensor, which has been amplified. Its normal point is 2.5 volts, and breathing in, exhaling and inhaling changes the pressure up and down. So the voltage variance at the moment is about plus or minus 1 volt either way. The twitchiness you can see is that I'm not using the full range. So basically the 0 to 5 volts is split into 1024 bits. The range I'm using is about 2 volts across that range, and then I'm amplifying my signal in the software times 4 to get across the 1024 range. So any noise is being amplified by a factor of 4 by choosing the correct gain on the op amp. So we're getting that 0 to 5 volts range in hardware will significantly decrease noise by a factor of 4, and then any extra smoothing can be done in software to prevent this twitching. This is the breadboard. We have 2 voltage regulators, one 5 volt regulator which is powering the op amp. We have a 10 volt regulator which is supplying the 10 volts needed to excite the differential pressure sensor. The op amp is used, it's in a kind of differential mode, so it's monitoring the difference between 2 voltage inputs, and they are the 2 voltage outputs from the pressure differential sensor. I'm currently supplying the Arduino with power via the USB cable, and also power via a 9 volt power supply unit. it's not best practice because there are ground issues all over the place, because I'm supplying the breadboard with a third power supply, which is supplying around 11 volts, which is being regulated down to 5 and 10 respectively. Ideally we want one power supply with one ground across all boards. Again, this will prevent noise of any kind. And I'm just monitoring here. You can see the voltage differential, the voltage output of the op amp here. As you see, without any breathing, I'm getting around 2.5 volts. And this is the kind of bong arrangement I've created, which uses two pipes of different diameters, and then with this central chamber, which is made using a plastic bottle, which is only there to smooth the airflow between these two pipes. It's kind of standard practice in wind tunnel to try and make the airflow laminar in a wind tunnel. So I'm just taking static pressure off both tubes, and then this is fed back all the way down the cable, all the way down this static line into this differential pressure sensor. I actually found that monitoring the pressure only in the rear tube and comparing that to atmospheric pressure gives a really good reading, because actually using the front pressure gauge, which for the calculations should be right, the pressure differential when you inhale is significantly smaller than exhaling. But as I say, just using one pressure measurement and comparing that to atmospheric pressure at constant, you'll see we get a very good flow rate indication for both inhaling and exhaling. You can see here the two different bore size end caps. I made a series of end caps here. Basically, the more restricted the bore size of the exhaust is, the higher the pressure differential between input and output. Obviously it's a juggling act, because the smaller the bore size, the more difficult it is to breathe. But this one I've currently got on here, you can satisfactorily breathe out very quickly and still give a decent pressure differential. We're currently using a 0.5, so 0 to 0.5 psi pressure differential sensor, which is about the smallest I can get. It's about £14.